Okay, so now we already took care of all of the quicks, so now we're just going to work on what are the longs, and maybe some of these will be nevers, but we're just going to call all of them longs so we can get through all the problems. Okay, so problem number 2 looked like it would take a long time, so we're going to go ahead and look at that problem as a u substitution. So we're going to let u equal negative 4x, and then the derivative of u with respect to x is going to be negative 4. So then getting dx by itself, we'll get the derivative of u divided by negative 4 is equal to dx. And then don't forget to change the values from 0 and 1. So the value at 1 is negative 4, and the value at 0 is still 0. So now the integral reads 0 to negative 4, e to the u, and then du. Then we have that divide by negative 4, so I'll make that a coefficient of negative 1/4. Anti-deriving e to the u is just e to the u. And then using the fundamental theorem of calculus, replacing in the value of negative 4 and 0, we get negative 1/4 e to the negative 4 minus negative 1/4 e to the 0. So we have negative 1/4 e to the negative 4, so I'm going to look at my choices. So we're going to get rid of anything that doesn't have the negative 1/4 e to the negative 4, and that's going to make plus 1/4, which that's what D has right there, so we're going to choose letter D. For problem number 3, we're looking for which of the following statements are going to be true. We know we have a horizontal line that's going to be an asymptote for the graph of f. So if you just kind of imagine that graph of f having a horizontal asymptote at that number 2. Okay, horizontal asymptote means as x heads towards infinity, the graph is going to go towards the number 2, or as x heads towards negative infinity, the graph might be coming up towards the number 2. So I'm going to be looking for that as one of my statements. F of 0 equals 2, not that one, not that one. As x heads towards 2, nope. As x heads towards infinity, f of x is equal to 2, so it's letter E. Okay, in problem number 7, we want to know which of the following statements are going to be true about f, but we've been given the graph of f prime. Okay, so if this is the graph of f prime, and we know that f prime is above the x-axis, that means f prime is going to be positive. And when f prime is positive, that's going to let us know that the original function would be increasing. So in the section from negative 2 to 0, we know f is going to be increasing. So I'm really liking letter B, but let me just double check. On f prime now is negative, so when f prime is less than 0, that would mean that the original function f would be decreasing. And it says f is decreasing from negative 1 to 1, so I don't like that answer. I still like B, I'm going to keep that right now. F is increasing from 1 to 2. Nope, we said f was decreasing, so not that choice. F has a local minimum at x equals 0. Well, in order to have a minimum, f prime would have to change from negative to positive, because that would make the f graph decrease and then increase, so it can't be a minimum. And then f is not differentiable at x equals negative 1 and 1. Well, we found out that f prime was a positive answer, so positive means differentiable, and same thing for 1, a negative answer was differentiable, so we don't like that choice. We are choosing B. Okay, for number 9, we're looking for f prime of 0. We can see this is going to be a chain, that function that's inside natural log. So to get the derivative, we're going to go ahead and derive the inside, which would be 1. Derivative 4 is 0, plus then the derivative e to the negative 3x is going to be the derivative of the inside, which is negative 3, then e to the negative 3x, and then all of that's going to get multiplied by the derivative of natural log, which is 1 over that function. So 1 over x plus 4 plus e to the negative 3x. We need to replace in the value of 0, so let's go ahead and do that right now. So we get 1 and then minus 3 e to the 0, and then we have 1 over, well, that's just going to be 0, so 4 plus and then e to the 0. Okay, we know e to the 0 is just 1, so this is going to read 1 minus 3. Again, e to the 0 is just 1, so that's 4 plus 1. So we're looking for a denominator of 5, a numerator of negative 2, and that's going to be letter A. So the next thing that we're given is that f prime of x is also negative. So if f prime is going to be negative, then that means that f is going to be decreasing. So we're looking for a graph where the function is decreasing. So a is not increasing the whole time. We have some increasing and decreasing, so we'll get rid of a. B is decreasing the entire time. C is actually increasing, so we'll go ahead and get rid of C. And D is decreasing, so we're going to keep D. So now we're down to B or D, and so the last bit of information says that F double prime is going to be negative, and when F double prime is negative, that means that F is going to be concave down. So I'm looking for which of those two graphs has F being concave down, and D has some concave down and then some concave up, so I'm not picking D. Then I go back and look at B, and I can see that the graph is concave down or curved down the entire time. So we're going to go ahead and choose a letter B. Okay, so problem number 11 tells us that we should be using u substitutions, so they already tell us what the u should be. So we need the derivative of u with respect to x, which is going to be 2. So the derivative of u divided by 2 is equal to dx. Then we go back to our integral, and we know we're going to have the integral of the square root of u, but then we have du over 2, so we have du. I'm going to go ahead and move that divided by 2 as the coefficient, so I'm looking for a problem that has a 1/2, so not d and not e. And then I've got my interval, which is from 0 to 2, but I need those to be in terms of u, so I'm going to go ahead and replace in that value of 0 in, so u is going to be 1 now. And then replace the value of 2 in, and so now u is going to be 5. So I'm looking for the integral from 1 to 5, and that's letter C. So problem number 12, let's read. It says the rate of change of volume, and we're trying to write a differential equation. So A and B are not differential equations, and it doesn't talk about the rate of change of volume, which is going to be dV dt. Then it says if a water tank with respect to time is directly proportional. So directly proportional means we're going to multiply by some constant. So that's going to be equal k times something. Okay, so that's going to get rid of letter D. And then it says the square root of volume. So we're going to go ahead and square root V for volume. They told us V was going to be volume. And so then it's letter E. So in problem number 14, we're going to need to get the derivative. And we can see there's two different functions, so we're going to have to do the product rule. So the derivative is going to be g, which is sine of 2x, times f prime, which is 2x, plus then f, which is x squared, and then the derivative of sine of 2x is going to be a chain. Derivative of the inside is 2, derivative of the outside is cosine, and keep the inside the same. So a matter of simplifying, I'm looking for a problem that has an addition sign and has two terms, so it's not going to be a or b. I also don't see an addition in d, so I'm going to get rid of that one. And just rearranging the terms, I can see I've got a 2x sine of 2x plus a 2x squared cosine of 2x. And if I distribute in on c, that doesn't equate. But if I distribute in for e, that would be equivalent. For number 15, they gave us the derivative as this function, and we want to know when f is decreasing. And f is decreasing whenever f prime is going to be negative. So they've given us f prime already. I'm going to go ahead and take that derivative and set that equal to 0 to find the critical numbers. So that'll make x squared is equal to 2 over x. Multiply both sides by the x. We'll have x cubed is equal to 2. So x is equal to the cube root of 2, which is a critical number. So when we make our f prime number line, that cube root of 2 is going to be on the number line. That'll be the critical number. So probably not C, B, or A. All right, so then I need a test number. Well, a number that's easy to test would be something like 10, something larger than what the cube root of 2 is. So 10 squared is going to be 100, and then take away 2 over 10, it's still going to be a positive. So this side is going to be positive, which means f would be increasing. I want f to decrease, so it's got to be the section over here. So we're going to go ahead and choose letter D. So in problem number 16, they say that we have a tangent line, and that tangent line is going to be the graph through this point and passes through that point. So if we're talking about f prime of 1 means the slope of the tangent line at x is equal to 1. So what is the slope of this line? It's just y2 minus y1 over x2 minus x1. So negative 9 over negative 3, which is then 3.